Fine. Yeah, no, that's okay. It's just it's like anything. I've got a microphone positioned, so I was talking quietly. Sometimes it can be loud.
Yeah, okay. So, John, we are going live and I'll let you know when you'll have to speak, okay?
Okay.
Okay, great. Hello, everyone. So, let's welcome our next speaker, John McFall. He is the CEO of Supply Chain Wise, and we thank Supply Chain Wise for the support and generative talk. So, John is a trusted senior executive and well known figure in the tech industry, bringing over 2 decades of experience in business strategy and sales leadership. Throughout his career, he has worked with prominent names in defense, retail, and technology, including the Royal Air Force and Amazon. He's currently serving as the head of Amazon Web Service, Supply Chain, Transportation, and Logistics Business Development Team, responsible for driving global sales and business growth across public and private sector markets. He is renowned for his strategic insights and ability to spur growth in complex and fast paced markets, and is passionate about guiding clients through transformations to achieve measurable outcomes. John builds and lead high performing diverse team. This is a cornerstone attribute. He will be sharing his insights on revolutionizing logistic and supply chain, Gen AI's uncharted for frontiers in efficiency and resilience and innovation. Over to you, John.
Excellent. Megan, you make me feel very old with multiple decades of experience, etc. Oh my goodness. Lots to live up to. Well, look, guys, thanks very much for having us. It's great to partner with the Digital Logistics Conference and PTN events, more importantly. So Supply Chain Wise itself, we are a new organization, been around for the best part of 5 months, built up with people from Amazon Web Services and Amazon.com. Our main driver as an organization has been very much around this notion that so many organizations try to outsource supply chain. It's a cost-cutting measure. It's a cost center which we continuously optimize. We'd like to think about it differently. We like to think about supply chains being something that can fuel growth, something that can create new ways of doing business, create new customer experiences and satisfactions, and of course, add strategic value for our investors. We're born and bred in the cloud, and for those that are sitting on-premise locations, etc., with their IT infrastructure, we really do firmly believe that the future is the public cloud, and therefore, we bring the cloud to bear with the supply chain knowledge. The other aspect is that whilst AI and data are not going to solve every problem in your supply chain, they do help solve some transformational changes. And therefore, bringing those three things together does fundamentally help change how supply chains operate. Whenever we are looking at the use of generative AI for the purpose of changing how an organization might deploy in the future, it's important to think about where you are personally on this digital spectrum as an organization. Whenever we look at this, it's, sometimes it can be quite tricky because on the nascent side, we have a lot of customers that are still using Excel and Microsoft Outlook as the main means of coordinating activity in their business. So they're using Excel to do their planning, their inventory coordination and controls, and they're using Microsoft Outlook as their primary means of communication with external customers and internally as teams. And of course, it means you can't really gain that real-time visibility and you can't function with a large amount of agility, because we're having to coordinate activity in a very painful and mandrolic way. But an area that is maybe even more frustrating than being nascent is the notion of being emerging. And in this emerging market, what we see are people that have purchased best of breed capabilities. They've got your Blue Yonder planning systems. They've got your Infosys warehouse management system. They have an SAP core, but still frustrated because a lot of these systems don't work together in a coordinated way. You still can't quite get that end-to-end feeling that you desired in your supply chain. And when you want to get information, you have to download it into the CSV file anyway, pivot table it, and then create an email and send out the information. So when we're talking to people, what we push for is this notion of automation. The desire to have as many decisions either supported and or fully automated in your workflows. And I would hesitate to sort of say that this should be the end state, because I do push towards integration. But for the purpose of the conversation we're going to have today about generative AI, it's important to recognize that getting into emerging is not the end state. And you should be thinking about automation, because that's where the generative AI tool is going to help the most. So focusing on that then, Amazon.com itself, let's use that as a case study. So Amazon, when we talk about unprecedented scale, Amazon has circa 250 million unique products, 450 odd million at the SKU level, across more than 200 facilities that it owns and operates. But it's not really the end of the Amazon story. That's not really unprecedented scale. What I want you to reflect upon is that Amazon, like everyone else in this business, is dependent upon Maersk, the MSCs, the Kuehne+Nagels, the Crowleys. It's dependent upon the J.B. Hunts, the Eddie Stobarts of the world to move the middle mile. In the last mile, it's even more complex, right? Because it's got Royal Mail, it's got UPS, it's got their own delivery capabilities. So really the unprecedented scale is more to do with the coordination of activity across the global middle and last miles to move that volume. And that is all of it underpinned by advanced analytics, generative AI, and machine learning. When we then look at the next aspect of this, which is hyperspeed, the technology aspect would be the 29 million transactions per second over the Amazon website, super fast numbers of transactions, which is interesting. But we're all logistics professionals. We're more interested in how long does it take to move a product to the customer. So if we look at something like Amazon's busiest day, which would be our busiest quarter, which would be Q4, and at the busiest market, which would be the US, at the height of the pandemic, Amazon was able to move a product to the hand of the customer in 29 minutes and 54 seconds. 29 minutes and 54 seconds. That's despite the operational challenges of being the busiest quarter, busiest day in the busiest market, and the operational constraints caused by COVID. But of course, it's not true to say that Amazon would be moving a washing machine in 29 minutes, 54 seconds across Manhattan anytime soon. Instead, what we have to do is we are having to use the tools and systems to be able to identify that number of SKU that could be moved rapidly, i.e. held in small fulfillment centers close to the operational base. What is more, we would also have to be able to understand what SKUs that our customers would require in sub-hour delivery, which is the promise that is made. And then, of course, we would have to understand the price point associated with that. So really, when we talk about unprecedented or hyperspeed, what we're actually seeing is AI and ML at scale. What we're actually seeing is the ability to coordinate activity rapidly across the entire supply chain. Then, of course, Amazon, relentless innovation and customer obsession, but I won't label those points for the moment. The next aspect that we have to then think about is that if Amazon is doing all of this coordination, how does it orchestrate itself to be able to do so? So let's take a look at inbound operations. When we look at inbound operations, Amazon has more than 50 different systems doing nothing but looking at the volume coming towards the business. So from that perspective, on the one hand, what we're seeing is a huge amount of intelligence being applied to the data. What volume is coming to me over what channel? Have I got the right truck fill rates? Am I using the right spot market for the global mile, etc.? And we're doing one aspect of that is to do with inventory planning and control. So now we know with the volume that is coming toward a particular country. And then what we want to assess is by the SKU level. There's no point in knowing you've got 29 million units arriving tomorrow if those 29 million units happen to be washing machines distinct from memory sticks. It's going to have a fundamental difference in your storage capacity. So therefore, we need to be able to predict at the SKU level what's coming towards us. We need to understand the space in any given fulfillment center. We need to understand the processing time in any fulfillment center, and we need to be able to demonstrate in a simulation how all of that volume is going to be moved sufficiently and effectively through the supply chain towards the end customer based on current demand, forecasted demand, etc. And those simulations are happening frequently. But of course, it wouldn't be possible to manage those simulations in a simple Excel basis. So therefore, all of this is being built into advanced analytical tools. So the other aspect of that, though, is that sometimes you're going to deal with large customers that will be able to provide automatic integration into your systems. And you're also going to have some customers that are going to require manual entry. So in the top line, you have a vendor-fed process that's coming in through API, so digitally fed into the system. And at the bottom, you have a manual portal where people can type in their produce that's moving towards you. That creates the operational picture. Now, the reason why I want to share this with you is because what you're seeing in the Amazon example is generative AI and ML being used at scale in order to facilitate that operation. And whenever people then say to me, John, why? Well, it's because Amazon wants to answer this one simple question about everything that it does. So imagine in your own environment, if you knew something was going to happen, 95% certain something is going to happen, would you do anything differently? And take a moment to just reflect upon it. Because if the answer to that is no, then it's okay. You don't need the data. You don't need to worry about it because you're going to let the train crash anyway. You're going to take no action. But if the answer is absolutely, then the trick then becomes understanding what data you need, the level of accuracy of that data you require in order that you can then make the decisions. And it could be something really simple. So the commentator before me was talking about Poland, Central Europe, and distribution of volume. So what would we do differently if we knew for sure that a main arterial routeway between the Czech Republic and Germany was going to be blocked or severely disrupted for 24 hours, starting in 48 hours time? There's a huge amount of potential rerouting opportunities to be able to move the volume around different areas, potentially taking volume from different fulfillment centers, maybe even looking at our global mile and points of entry to see whether we need to inbound to different countries to continue to facilitate that movement. And those decisions are complex if you're nascent, going back to that model of Excel using Microsoft Outlook and the telephone to coordinate activity. They're somewhat problematic if you're emerging because you'll have the data, you can pull it all together and you can start to look at the picture. But if you have automated systems, the ability to close a road would result in a new simulation of the distribution network and an automatic resimulation of your load balancing and provide you with options as to what you should do next, or alternatively, fully automate what's going to happen for the next 48 hours. So reflect upon what you could do differently if you had the data and the automated systems in place. Ultimately, what we want to do is be able to put authority where the data is. And this is an important aspect of leadership. We often try to centralize decision-making, but in a central location, we may not actually have the appropriate data to be able to make the accurate decision. So therefore, it is important that we are able to have people with the right access, with the right information to make decisions. And if that's the case, then we need a decentralized model, and we need the ability to understand how those decisions flow through the rest of the chain. And that means simple things, like if a fulfillment center leader opts to use a different distribution mode because he recognizes or she recognizes a current challenge with their last mile delivery agent, then the implications of that could be that you actually exceed your contractual rates with the other vendor. And that may be an unintended consequence, but it could result in a very significant overage in terms of cost. So all of this then pushes towards this notion of what we refer to as a serverless supply chain. And if you have a look at this model, really what we're setting out is a notion where you have a common user interface, so the area in the arc around the outside, where you have intelligent decision support, where you're able to get connected products, etc. Underneath that, at the very bottom, you have your infrastructure layer. And you will hear people often talk about the notion of clean core. Well, this is it. This is using your ERP system to do what ERP systems do. On top of that, you then have your application layer. And in these areas, what you can see are your warehouse management system, your order management systems, etc. And on top of that, what you have are your best of breed capabilities. That could be an S&OP system, it could be a freight management system, could be a fuel optimizer, distributed order management, whatever it's going to be. And all of those systems will hopefully be built with the right level of coordination to work together. But the bit that I skipped over is the little box that says supply chain wise GenAI orchestration engine. Traditionally, you will all maybe have played with ChatGPT, and you will have asked ChatGPT some basic questions, and it will come back with amazing answers. It could even write code and all sorts of cool stuff. But it'll always tell you that its data is as of September 2021. What is more, all of the questions and all of the data and all of the inputs that you're asking, you're sending that out of your organization into a third-party application where you're training the model, and also you're exposing your hopefully not your customer data, but you're exposing some of your own thoughts and your own process to this third-party agent. What we propose is different. What we propose is that the generative AI needs to be put to work inside your context. So that means that we might take input from external sources, whether it be an Everstream data around your end-tier supply base, or whether it be even a conversation from ChatGPT in terms of VBA coding or what have you. But let's take the Everstream example. If Everstream were able to provide me with a breakdown of the supply risk around my environment, I'm able to tell Everstream, I've got vendors in Taiwan, North Africa, Mexico, wherever it is. Everstream will then provide me with a host of data that will explain where the operational challenges are with those vendors, which is good. But if I can take that data into my supply chain and I can say, based on the perceived risk of sub-Saharan Africa as a result of X, Y, and Z occurring geopolitical risks, what are the implications for my supply chain? I don't want a weather forecast anymore. I don't want in broad order what's going to happen. I want to know that I have got 2 vendors from Kenya that provide me with, foam that goes into my seat, and that seat is fitted into my specific model of vehicle, and that specific model of vehicle is in high demand, and you only have 2 days worth of coverage. That's what I want to know, because then I can articulate what the effect is going to be. And that's where these large language models, this generative AI tooling, becomes super helpful, because they're able to cut through all of the data. They're able to go around all of the various tools, your distributed order management system, your end-tier supplier system, your external Everstream feed, whatever you're using, and it's able to bring all of that data together in order to create a better decision support profile for you as the customer. So when you reflect upon then how this system works, the most important aspect is that we're trying to remove the notion of swivel chairs, so that we don't have 200 passwords to access each of those bubbles. We don't have a further suite of passwords in our SAP system, etc. Instead, what we're able to do is create a fully coordinated activity across all of those workflows. And of course, whenever we finish that, everyone's like, yeah, John, that's exactly what we want. That's what we're looking for, and that's going to help us greatly. And that's true, but then the question is, where do you start? How do you even go about thinking about this sort of thing? And that can be quite a tough exercise. But the most important thing when you go on this journey is to not try to solve everything in one go, looking for this, what in IT terms would be referred to as a waterfall moment, the moment at which everything suddenly works. Because if you do that, you're going to fail. So let's show how we potentially go about doing this. The first instance is to list all of your use cases. And your use cases in this terms is to identify those things that are causing genuine business pain. And it can be the usual: fuel, driver shortages, inventory optimization, warehouse capacity, it doesn't matter. List them, labor planning, list them, identify all the use cases. Then what we're going to do is to buy, build, and partner the supply chain platform that you need to solve each of those individual use cases. Then you're going to ingest the data that you need to solve for those use cases. If you were to do this the other way around, ingest data, build platform, find use case, you would have spent a fortune, you would have created a behemoth of an application, and you'll be wrong, because all you'll have is a hammer, and you'll be looking for everything to look like a nail. You will not be able to solve the problems in a nuanced way. So use case, build what you need to build by, partner what you need to solve for it, ingest the data that you need. So the other thing that we talked about was punching through the target, that notion of not just doing emerging, but looking for automation. And there's a whole host of really good AI tooling out there at the moment. And we all know you can read a registration plate from a vehicle, and we know that we can pull data from the sides of vehicles. We can even pull information off the carrier, who the vendor is, who the transportation company are. We can pull data off the sea container. And Navtrack do a great job at bringing all of this information together. But think about automation. It's not good enough to just simply be able to pull the registration plate. If I have a purchase order and I manifest, and I know that the truck has come together, I can have my gatehouse autonomously open the barrier. I can even have a sign that says truck 1, lane 1, because I know what's in there. I could have an indicator coming into my warehouse inbound operations team. That truckload of PlayStation 4s that you wanted, or maybe 5s, whatever number we're on, has just arrived at the gatehouse and needs to be prioritized. It could be even used in the instances of lining vehicles up for ferries or whatever. So the point is, don't just think about I can read the plate, useful. Think about the next stages. If you know that the purchase order's worth of volume has just arrived for your gatehouse, can you automate the settling of your invoice? Can you notify the vendor? Can you notify your end customer that the volume is moving? Other aspects is trying to enhance the situational awareness around things like driver safety, etc. So we can use advanced analytics and generative AI tooling, and in this case AI tooling, to be able to look at things like driver distraction, in-car behavior in terms of distance keeping and whatever else. We could use it for making sure that you don't have trucks driving through small villages if you, the truck operator, have asked your drivers to avoid that due to complaints from locals, etc. So in this instance, we're able to help and support driver behavior. But of course, we can then link this sort of systems into driver credentials. So if a driver is frequently unsafe, we could remove the credentials, and then we could automate you can't take the key out of the keypad because you have actually lost your credentials to drive until you go and speak to the safety officer, for example. So we can use these and link these things to be able to drive ever better decisions across the network. Getting into a bit more of the risk management, then we can use AI and ML to be able to do things like weather forecasting. We know weather forecasting is pretty accurate, cool. But here you can see a map between Barcelona and Madrid where it's currently raining. And that's useful because what the data science team have done is identify the route between these two locations. They've identified which portions of that route is subject to adverse weather. They've applied a speed penalty to a 40-foot truck, not a car, not a motorbike, 40-foot truck driving on that journey. And they've recognized it's going to take 12 additional hours to complete that journey. That 12 hours can then be applied to the ship method. And when applied to the ship method, we can then autonomously update the customer promise. We can update whether that's the best route to use. Should we take it from a different warehouse instead? And we can also update the warehouses for the distribution of volume autonomously. If you look at something like planning times for vehicles, you could have a requirement to know at what time does a truck need to leave my facility in order to inject the volume into the next part of the jigsaw as we move towards the last mile. And in this case, we call them critical pull times in Amazon. But the idea here is that you're going to identify, is it a team of drivers, single driver, trailer driver, whatever, van rather than truck. You're going to identify the traffic, the flow, you're going to identify all of those factors, and you're going to punch out feasible critical pull times so you know when trucks need to leave by in order to inject volume. So what? Well, that means you also then understand that if the truck needs to leave by 1700, that means it takes you 30 minutes to fill the truck. Then at 1630, you can no longer be picking new volume to put onto the truck. If it takes you 30 minutes to pick your last order, then it means that at 1530, you can no longer have new orders drop, which means that the website for e-commerce needs to be updated with a promise. And that's why you see that continuous clock evolving on Amazon, because they're constantly watching critical pull times. And of course, they can fluctuate. So what am I getting at is that this notion of last mile optimization is another fantastic use case of AI, ML, and in some cases, generative AI, because it is a complex challenge, but it's mathematical. As too is the challenge around network topology planning. So you have multiple networks, which is the best paths to move volume around. Let's not try to plan that on whiteboards, magnets, and pens and papers. We can do it with math. We can run the simulations and we can identify the best path to move the volume, depending upon time of day, price of the vehicles, the current routing, etc. And in fact, carbon emissions, etc. All of those things can be built into your model. You can then create really interesting use cases around how do you optimize. This is a look at Amazon Transportation Services. And what you find is that you're able to optimize the waves. So in this particular case, if you're given 72 hours notice, you're still getting a 12% improvement in truck fills. If you look at that bottom one with 2 to 78 weeks notice, you're getting 29% improvement. You know, what would it mean for your business if you were to get a 20% improvement in your truck fill rates? or if you were able to improve the fuel efficiency across your entire fleet by 20%, or reduce the cost of labor across your warehousing by 20%, what impact would it have on your business? What would be the value? Other aspects of this is things like dynamic simulations for what-if scenarios. And the classic example within the Amazon business would be Fulfill the Promise. And in the Fulfill the Promise engine, what you have is a sophisticated tool that is able to look at where the customer is, what they've ordered, which fulfillment centers, the ones represented in green, have the order and can meet promise, and which fulfillment centers have the inventory but can't meet promise, represented in blue. What the system then does is look at all the criteria that you've given it, unit ship price, carbon, whatever, looks at all of those, and then it then identifies autonomously which is the best site from which to send the volume. And of course, that could change throughout the day. So RE4 might be the cheapest site today, but if by lunchtime we have a change in manning or a change in operation, the variable cost of production could have gone up, in which case it's okay, we're going to autonomously swap to Leo 1, as long as Leo 1 can still meet promise, and so it changes throughout the day. So therefore, you're able to put your charge to where the current operational requirements are. And a system like that enables Amazon to be able to deal with failover. So if RE4 was suddenly not available, Leo 1, if all of the French sites were not available, SVQ1, etc. It also means you're able to prioritize the customer promise. Now, I've shown you an individual customer for an individual SKU, but of course that could have been a fulfillment center, a wholesaler, it doesn't matter. The principles are exactly the same. But not everyone is as complicated network as Amazon. And therefore, what is also possible is to refactor the sort of thinking and create distributed order management systems. And this is one particular example that was built for a large brewer that enables you to be able to look at the dynamic planning of volume movement across a network based on the criteria you see on the left.
John, I'm so sorry to interrupt you in between, but the session time is up and we have other speaker online.
Okay.
I'm so sorry for...
I was just about to finish, but okay.
Yeah, you can do it. You can do it for sure. You can continue.
Okay, guys, sorry for the interruption. To conclude then, there's effectively one thing that I wanted to bring out, which was do not seek end-to-end visibility as an end state. It's just simply not worth the hassle. What you want is you want predictive analytics, you want prescriptive guidance, and you want to fight towards automation. Ultimately, you want to be progressively increasing value with actionable insights. And ladies and gentlemen, that is it from me. Thank you very much for taking the time to listen.
Thank you so much for very engaging talk, John. It was an excellent talk, and I would actually look out for the opportunities to listen to your sessions more. I thank you on behalf of the whole PTN events team, and we are truly honored to have you on board with us. I apologize to tell you this, that we won't be able to take the Q&A because the time is already up, but I'll request all the attendees to put their questions directly in the chat box, and they can do it by visiting the attendees tab on the Hubilo website. Thank you once again, John.
Thank you, guys.
Thank you.